Hello, everyone, and here we are again with another episode of IHS Laboratory blog, Speak Up. And today we're going to be talking about mass timber with Emeritus Professor Dr. Andy Buchanan. Dr. Andy was a pioneer and considered to be a pioneer of timber construction. He's been working as a timber in timber engineering, in earthquake engineering, in fire engineering, converting cutting-edge research results into industry practice. He used to be the president of New Zealand Timber Society, and he also the author of Structural Design for Fire Safety and New Zealand Timber Design Guide. So Dr. Andy Buchanan used to be a professor of University of Canterbury for many years, and he was the one who was working towards establishing qualification of master's degree in fire engineering. So Dr. Andy Buchanan, thank you so much for joining me today.
Good. It's my pleasure, Anna.
Yeah, so getting back to our mass timber topic, there are so many pros around mass timber. Surely it's cost saving on the foundation due to the light structure. It's quick and easy to handle on site. It's surely smaller carbon footprint if compared with the conventional building materials as concrete and steel. But the cons are also there. For instance, a very recent report from John Hopkins University on the performance of mass timber in high-rise buildings has actually spurred a lot of questions and disrupted the views of many supporters of mass timber, even here in New Zealand. I know you've read it, so my first question will be in regard to that, and I'll read the statement from this report, if you allow me. So the use of mass timber for high-rise structures requires special consideration due to the material's combustible nature. As knowledge gaps remain, for instance, self-extinction, fire dynamics, delamination, and no return of experience exists on fires in high-rise timber buildings, caution should be exercised. So could you please elaborate on those phrases such as special consideration or caution should be exercised? So what's your opinion on that?
Okay, that's a very good question. The first point I would make about this is that this report, it's a very comprehensive report. It was commissioned by the steel industry, the World Steel Association. It's been circulated in New Zealand by the HERA, the Heavy Engineering Research Association. All I can say is these guys must be getting a bit frightened of timber coming on board, or they wouldn't have bothered to do this. But at the same time, the report is a very good report. It's an accurate report, and it does acknowledge, which we all acknowledge, that wood burns. It's a combustible material, and so we have to be careful about that. And if we just look at those, I want to pick out a few words from that quote you gave me. The first thing, it talks twice about high buildings. It talks about the use of mass timber for high-rise structures. And it also talks about no experience on fires in high-rise timber buildings, because we're not building timber skyscrapers. Mm-hmm. And I actually agree with this concern because wood burns. I think that the timber industry should be looking at 2, 3, 5, 10-story buildings, but I would have some reservations myself if we're talking about 20 stories or 50 stories in wood, just for the reasons mentioned. And also this question of self-extinguishment and delamination, because one of the principles of fire engineering is that when we have a tall building, which we have little access to, all of the principles of fire resistance are that we have we design the building in such a way that if there's a fire in one room or one floor, that fire can burn and can grow and decay without spreading to the upper floors or the other rooms, and eventually it will go out. And it will go out when all the fuel is burned. And as this report points out, we have a problem, a small problem, if this wood structure, because some of the fuel is actually in the structure and it won't be all gone. So all I would say is that I share their concerns, but as long as we consider this properly and take it into account, we can provide the same level of safety in a timber building as we could in a steel or concrete building.
I'm sure that the supporters of mass timber construction are right now clapping their hands listening to your speech. Thank you so much. So the next question is around... Yes?
Well, just before we go to that, I just want to say another thing about these tall buildings. Sorry. You might, because I would like to add one more thing about the timber in the building and the concerns of the steel industry. And the one way of managing this is to cover up some of the wood. So what we find in these mass timber buildings is sometimes we have a tension, a difference of opinion, because the architect and the building owner, they want to see all the wood. But the fire engineer says, I want to cover up all the wood. And so we have this tension which we have to compromise on a little bit. And I would say the taller the building is getting, the more we have to move towards, we expose less wood in a tall building than we would in a small building.
Right, agreed. So all of those products made of mass timber, PLT, CLT, so once incorporated into the project, so what are those compliance requirements which fire engineers are expected those products to be to meet those compliance parameters? And in your opinion, what's the most critical one?
Okay, well, first of all, in terms of compliance parameters in the New Zealand Building Code, there's no limitation on materials. It's possible to build a tall building of concrete, steel, or wood. There are no limitations. And of course, when the building code was written, nobody was thinking about tall timber buildings. So changes are coming. And I am in conversation with MB and the code writers because they're asking a lot of questions about what the code might look like, because we have the acceptable solution, we have the verification method, and we have an alternative solution. But in terms of what's the most important thing, there are two important things. The first one is, how severe is the fire likely to be in this building that we're talking about? In other words, how much fuel, how much ventilation, and what sort of fire are we likely to have? Because if it's going to be a very severe fire, then we need to take more precautions. And then, as I said before, the next important question is the height of the building, because as the height of the building increases, we need to take more precautions. I think what's important is to provide fire resistance. And this is perhaps a little controversial, but the fire resistance ratings in New Zealand for tall buildings, steel, concrete, or wood, are very low on international standards. If you have a tall building in New Zealand and you put in sprinklers, it's 30 minutes everywhere. Whereas in most parts of the world, it's 60, 90, 120 minutes. And so I think what we need to do in New Zealand is not only look at the building materials, but we need to look at the fire safety requirements for all of our buildings.
If this is the advice you're giving to the MB representatives?
Well, I would say this is something I'm going to point out to them. I'm not telling them what to do. That's their job. But if they're asking
for the guidance, right?
I'm going to point out this situation, because if you make a comparison, it's very clear that at the same time, we have to be careful because fires do not happen very often. And if we get carried away and we get conservative and we increase these fire resistance ratings, it makes buildings more expensive. In fact, it makes timber buildings very difficult because we have to add more and more wood and it makes them more expensive. So we have to have a balance.
Absolutely agree. Listen, getting to our last question. I know you've been touching on encapsulation topic with some of our clients, and also you were mentioning encapsulation in today's webinar. So encapsulation with the intumescent and encapsulation with a plasterboard. So if we compare them, so what kind of test might actually be useful to make that comparison, and whether at all you think that encapsulation with intumescent can be as effective as, for example, the one with the plasterboard?
Yes, well, that's also a very interesting question. So to start with, the building industry in New Zealand is very familiar with gypsum plasterboard, gypboard, which is a fantastic product in fire. And so that can do two things. It can protect the wood. If we have a thin layer of gypboard, it protects the wood for some time, and then charring may occur after some time, and the board will fall off and we get some more charring. And we might call that limited encapsulation. If we want to have full encapsulation, then we would be thinking about enough layers of board so that even after the fire is out, there's been no charring of the wood. And that is absolutely possible. And you can look at the one-way ratings and the gyp manual to find out how to do that. That works well. But there's a new material coming along, and that's just an intumescent painted finish. And the product I'm aware of is coming from the Tech Coatings company. And those people have developed a very nice white intumescent product, which can be used in the same way as gyp to provide some protection, some encapsulation. And I know that they have under development a clear finish. And if they can develop a clear finish, that will be very popular because people want to see the wood. If you go back to my original thing about the architects, they want to see the wood.
Right.
But so there's a lot of opportunity here. But as you say, this is, how do we know how these things work? There's only one way to know, and that is by testing. That's the only way to find out how good these things are. And we can start with small scale testing to get an idea, but to get a fire resistance, we need to do large scale tests to see if there's any problem with shrinkage or swelling or gaps opening up. And so that's where there's a very big opportunity for these manufacturers to work alongside your lab to do these tests. And the world of fire engineers and structural engineers will be watching very carefully to see what kind of tests and see the test results. So I hope that helps.
Oh, absolutely. Listen, I know we need to finish, but there's so many other questions. And I also hope that it won't be our last interview. So in the future, so if there are any questions or more inquiries, we will be able maybe to make it some kind of a tradition or some kind of a sessions in the future, because it's really interesting and very current topic for the discussion. But anyways, we need to finish. And thank you so much for accepting this invitation, and have a great day.
Okay, thank you. It's my pleasure. Bye-bye.
Bye.